In this video, we will look at the calculations required to analyze bonds of various types. We're going to start with the simplest situation, which are called the zero coupon bond. Now, we should note with bonds that the amounts they pay out are not called interest and not called dividends. They're called coupons. They used to be paid out with coupon books, and you turned in your coupon to get your amount. But zero coupon means there were no coupons. Savings bonds pretty much are this way. You have a face value. This is what they will pay when you turn them in. They have a present value, a purchase value of some value. This one is $17.72. You pay that out of your pocket. It's negative. And in 10 years, you will receive $25. And that is all the variables. If you know these three, the 25 to 3.5% and then the 10, and this should be like coupon rate, technically correct, although for zero coupon it does not make a lot of difference. If you know these three, there are no payments, so you can determine the present value as $17.72. This is another bond. If you know the face value is 100 and you have to pay $82 for it and you will get the 100 in 5 years, you can use the rate function to determine the interest rate. Rate 5 is the number of years, 82 is the present value, 100 is the future value. That is the zero coupon bond. Now, we've mentioned several things of terminology here. Let's just review those again. The present value is usually called P, the current price in bonds. In Excel, we have a future value, which they call the face value. The payments are called the coupon payments, so just coupons. Probably just coupons as people would generally refer to them as. The number of periods, just N, are periods to maturity, and it's yield to maturity, which we have looked at rates in most of our investments and loans and investments. Called it the rate. They call it a yield to maturity. In part they use this because there is a coupon rate, which we will see, which determines the coupons. And to separate the coupon rate from the rate of interest you earn, they call the second one the yield to maturity. The yield when your bond matures. If you played Monopoly, there was a sign, I think in the Chance or the Community Chest, one of the two, that come out that said your bonds have matured, collect $150 or something like that. That's where this comes from. Okay, let's now look at a situation where you have coupons, which is probably the more common one as far as volume is concerned of bonds. They have a face value, and you buy them at some price, and they mature in a certain number of years, in this case 5. Now in this case we have a coupon rate. That's not a dividend rate or anything, but that's the rate to determine what the coupon payments are. In this case it's 3%. This is an annual coupon. It comes out once a year, so it's 3% of 500, which gives you $15. That's the coupon. Then the yield to maturity, which is essentially the EAR, effective annual rate, can be determined using the rate function in this case. And C31 is the number of years, C33 is the coupon, the dividend, the payment, if you wish. C30 is the present value, which is $350. C29 is the future value, 39. 29, 39. I was pointing at the wrong chart. It is 29. Here's 29. So if we do this one, 31, 5 years, 33 is a payment, just $15. I was on the next chart. C30, 400, C29, 500. What the face value of what you get at maturity. And it computes out to be an 8.01 EAR, which is the yield to maturity. If we have quarterly coupons, it's a little more complex, not much, but a little bit. Same situation as here, 500, except the current price is $350. 5 years to maturity. We're going to deal with quarters here. It's a quarterly coupon, so there'll be 20 quarters of coupon payments. Coupon rate is 3%. Here's where the difference comes in. 3% of 500 is, what, $15. That's the annual. This is an annual rate, coupon rate. We have to divide that by 4. Here's the 500 times 3% divided by 4. So we take that $15 divided by 4, and each quarter you're going to get $3.75. That's probably, simple as it is, the most confusing part and error prone for everybody. With that, then you can compute a return, a yield to maturity, but first you have to get the quarterly. Since we're dealing with quarterly coupons, we're now dealing in quarterly. So the quarterly rate is simply C42, number of quarters, not years, quarters. The payment in each quarter is this $3.75. Present value is C40 to 350, C39. Now we have the right C39 as in $500. That gives you $271. 2.71% is the quarterly periodic interest rate. To get the EAR, which is the yield to maturity, we can use our equation. 1 plus that 2.71 to the 4th power minus 1 comes out to be 11.3%. That's the quarterly coupons. The other way you sometimes want to go is to determine a price that you ought to pay for a coupon. If you know what the face value is, that's written right on the bond. You have a criteria you use for your own investments, call it 10%. This bond has a 5-year maturity. The coupon rate is 3% annually. Again, this is back to annual. So the coupon payments are $15 annual. 3% of 500 is 15. And so the question is, what should I pay for this bond to get my yield to maturity of 10%? Well, you just use the present value of these. The rate is 10%. That's what you want to earn. Number of periods is 5 years. The payment is $15, and you're going to sell it for $500, which then comes out that you should buy the bond for no more than $367.32. If you buy it for less than that, your yield will be greater than 10%. You buy it for more than that, your yield will be less. You can do the same thing with quarterly coupons. Again, a $500 bond, 10% is, all this is the same as above. But now the coupon is quarterly, so we divide by 4. Determine the quarterly periodic interest rate, the PIR. Again, it's quarterly, so it's a little bit different. We take the 10% up here, which is in C61, 1 plus C61 to the 1/4 power minus 1, and you can get the periodic interest rate. Using that, then, we can find the present value. Again, we're dealing in quarters. C66 is the rate. Stay up there. Number of periods is the 20 quarters. C65 is the payment, the divot or coupon, $375, and future value is the $500. With all that in mind, if we pay $369.41 and sell it for $500 and receive our quarterly coupons at 3.75, we will attain our 10% yield to maturity. Again, if you buy it for less than that, you earn more. If you buy it for more than $369, you will earn less than your desired 10%.